Okay, so hello everyone. My name is 0xEvolve or Matthias. I worked at MakerDAO before for a year, and now I'm heavily contributing to the whole Starknet stack and co-founded a company called Pragma, which we're doing an oracle based on Madara actually, which I'm going to speak deeply about in this talk. So first of all, what is Madara? So we like to qualify it as a Starknet compatibility layer for Substrate. So if you might be familiar with Moonbeam Frontier especially, that's pretty much the same idea where we took Substrate and put the Caro VM into it. So what is actually the Caro VM? The Caro VM is a virtual machine developed by Starknet that is very, very handy because you can write any program in a Turing complete way. And this program will be provable in the way that you're able to generate a proof from the execution trace of your program. And that's a very, very powerful feature. Okay, so this is a bit about the architecture of Madara. So this is more related to, I would say, Ethereum, but yeah. So you have the transaction pool. All the transactions go in the transaction pool first. Then the sequencer, which is Madara in our case, picks up the transaction, validate the transaction, so basically the signature, then runs the transaction within the Caro VM and produces a block. So it communicates between the state, which is of course the substrate state layer, but we could add like different types of layer. And then there is a prover that is some actor that basically listens to what the sequencer is doing and takes the block and prove them and then settle that on the layer one or on any layer that has a verifier contract and that can verify the proofs. So that's a very simple view, I would say, but more than enough. And where does that come from? The idea was that, okay, we want to enable what we call fractal scaling. So the idea that we want to put layers and layers on top of each other, and Stark proofs and proofs in general help a lot with that because you could do a bunch of computation and just zip that into a proof, and at the end you only need to verify that proof. And the Caro VM is very handy for that. It's actually made and optimized for doing this. So that's pretty much how Starknet was born and how the idea of Madara came up. So first, I wanted to talk a bit about the spirit of Madara itself. There, we had like over 50 contributors and more that not even here. It's a fully open source project. Everyone here is welcome to come and contribute. We got a lot of people from a lot of different ecosystems. And yeah, it's always a pleasure for us to welcome new contributors. So just feel free to hop in the repo, which I will put the link after. Okay, so let's talk a bit about how an actual transaction works in Madara. So first you have some user that wants to interact with a smart contract. They send their transaction through the RPC. So I'll talk a bit more about the RPC after, but that's like the entry point mainly. Then there is one palette mainly in the whole project. We could have separated in many palettes, but we decided not for simplicity and efficiency. So you have the Starknet palette, which basically runs the Caro VM. So it decodes the transaction from the RPC, and runs it into the VM, and execute basically the whole like state transition logic. So making sure that yeah, everything is working fine and you're not trying to double spend or whatever. And then it updates, it interacts with the DB, so the rocks DB that Substrate is running. To update the state in real time. So like there is a whole state adapter, meaning that like the Caro VM directly interacts with the substrate storage. Oh. All right, and then once everything is done, it generates a block from all the transactions. So as you know, we can specify the block time. We tried with even block times as low as 250 milliseconds. So that's actually pretty nice. And then the whole part on the right, so like the data availability and the proving is not implemented yet, but that's what you would need to actually like finish this whole process. You need to verify, produce some proof and verify this proof, as well as posting the data on some place, on some data availability layer. All right, so I'll talk a bit more about the actual stack, because Madara is what we call a decentralized sequencer, but there is like a whole stack that comes with it. So the execution is done with Cairo, and that's like kind of the only place where you cannot change anything, because if you remove Cairo, you remove the whole provable aspect of Madara. Then there is the settlement. So here you need a Stark prover. You need this prover that is able to create a Stark proof from the Cairo transactions. So there is Shard, the Starkware prover, but other people are developing open source provers. So that's a very exciting field. Then there is the sequencing. So Madara can be tweaked in many ways. You could technically change the consensus. You could change like the way the whole sequencing works. But yeah, right now it's mostly Madara that handles that. And then you could choose your data availability layer. So for this, at the hackathon, there were some people that connected it to Celestia. There's the Polygon Avail team that is also working on connecting with it. But you could have like, yeah, any data availability layer. That's just where you put the data such that if the chain goes down, someone can rebuild it from scratch. And finally, the governance. So this is something that has not been worked on yet, and if someone worked to work on it, would be a pleasure. But basically, you have the default substrate governance palette, but that we could leverage, but there's also other solutions, such as Snapshot X, which is a solution developed on Starknet, leveraging Stark proofs as well. So here's the GitHub link if anyone wants to see. There are like much more information on this. All right, so let's talk a bit more about under the hood, because Madara is like, oh, as I say, a fully fledged stack. There are like many different pieces split into the stack. So first about how it's done, we followed like the frontier way of doing it. So with the block wrapper technique, so you have a substrate block, and within each substrate block, you have a Starknet block. That makes sure we have a perfect compatibility. Same thing for the RPC layer. There's like a perfect compatibility between the Starknet RPC spec and Madara. So you can like use all the tooling, the Starknet tooling and Polkadot.js tooling. You have the choice between both, and we actually use both in the test and in, yeah. So then we'll talk about benchmarkings and mock runtimes. Just wanted to say a few things. So out of the box, Madara comes with an Explorer. So you have, of course, the Polkadot Explorer, but you also have the Starknet Explorer. That's kind of the great thing with Madara. It's because it leverages both Polkadot technology and Starknet technology. We have access to both tooling and to everything that has been built around these two ecosystems. Then there is our infra, so we have like a fully DevOps stack with like Docker and Ansible and whatnot. So actually in one command, you can run your own custom Starknet out of the box. You just run a script and that's it. And finally, the doc site with a lot of documentation about everything I'm speaking about right now. So about the custom RPC, that was like one of the main pieces that we spent way more time on that we expected at first, mainly because making the RPC layer fully compatible with Starknet was very hard, because both of how the Starknet spec is designed and how Substrate actually wants you to design the RPC. But yeah, we finally did it, and so you can use perfectly the all Starknet JS tooling. There's like no difference between using Starknet and a Madara chain right now. Yeah, and so we leverage also the runtime API to basically communicate between what's happening in the runtime and the RPC. And I think there are a lot of great resources within the repo to learn more about these kind of things. Then I'll talk a bit about the benchmark, because I think that's something that we didn't see in like many substrate chains anywhere, but we have like a benchmarking page where you can see every time there is a new pull request merge in the main branch, it updates like the average TPS and a bunch of other metrics. And I think that's pretty cool to like always see how your chain is evolving, if you're not like downgrading the performance of your chain. And so for this, we leverage both the manual sealing of substrate, so the way like you can create blocks on demand, and artillery substrate. So actually we're going to change that, but that was like pretty useful for until now, but we want to move to some Rust, custom Rust solution. But yeah, so here you can see like the TPS, average TPS around like all the latest commits. Yeah, and I really think more substrate chains should have that. Then a pretty cool thing someone built in the community is the Madara app. So it's like a app you can install on your Mac. You just run it, and you have like a full node connected to the Madara testnet with like logs, with telemetry. We can stop your node on demand. And like, yeah, that's the kind of things that people are building, and I think are pretty cool. Just making it very, very easy for someone to connect, run a full node on your network, or even run a validator in the future. Yeah. Okay, so a bit about what's next. In terms of challenges ahead, there are many. Especially as you might know, no STD compatibility is a hard problem. So every time you want to integrate some VM or like some logic coming from other crates, you have to make them no STD compatible, and that's hard. So I think like the whole Substrate community should aim towards making it very easy for everyone to implement no STD compatibility, such that we can use like more and more external logic into our chains. Then multiple runtime configs. I think that's very interesting problems as well. How can you run tests? Again, like a lot of different runtime configs. So like with different hashing function, with different palettes configuration. This is not something that we found, so it's a pretty neat problem. Then weight benchmarking based on Cairo steps. So right now, all the extrinsics are basically unsigned and with like zero weight. And that's something that could be problematic, could be like a vector of attack. So we need to implement some benchmarking based on the Cairo steps, which is like the unit of measure of like to represent computation in the Cairo VM. And finally, the new benchmarking tooling in Rust that would be like a very useful tool to anyone building chains, I think, like to stress test your chain, your RPC, and just flood it with like a bunch of transactions and like benchmark or do whatever you want. And finally, the road to production, because all of this is running right now. There are like many people building testnets and demos and whatnot with Madara, but there is a big gap between what's live now and like the actual production chains in mainnet with real money. So we're exploring Tendermint into Substrate. That's something that hasn't been done before. At least we didn't find a good implementation. Then there is the whole staking part, the data availability scheme. So like, how do you, at the end of each block, you need to like put this data somewhere, whether it's Ethereum or some Celestia or whatnot. Then the proving integration is like a very tricky part to do. There are many interesting research in that field. The storage layout as well. So as you know, like Substrate comes with like its default storage layout with Merkle mountain ranges and things like this. But we think that we need to investigate other storage layouts that are like way more optimized for different use cases. And that will like help a lot with performance. And yeah, based on your use case, you might not need like a very complex storage layout, and it could be way more simpler. Then optimization, like the current implementation we did is definitely not heavily optimized, especially we have a lot of types conversion between like all different Starknet types, substrate types, wrappers, and things like this, just to make all that work. But yeah, there is like a bunch of room for optimization. So if there are any people experience with like substrate optimization, please come and contribute. Shared sequencing layer is a very interesting thing. Basically, you want to have like a lot of Madara chains that all users are just interacting with one shared sequencing layer. And then it handles like all the making sure there is no harmful MEV, making sure maybe your transactions are private through encrypted mempools. And there is like a very good team called Radius working on this problem. So yeah, exciting to see what will happen. And finally, storage proofs. So that's pretty much like bridging. How can you prove that some storage piece on the Madara chain is, and you just verify the storage on any other chain, Ethereum, Polkadot, or anything else. That's very important for interoperability and just communication between the chains. And finally, adoption, of course. Yeah, we've been working on that for the last, I think, five months or so. But we hope to see many more people building on Madara and bringing app chains to production. So yeah, thank you for listening.
Thank you.
Are there any questions?
Merci. Yeah, thank you very much. That's very interesting to see what you guys have built already. As for the Polkadot ecosystem, I would have actually two questions. Because first of all, we can see that you guys have built with Starknet a very complete set of tools. And is there any way today or planned in the future for other substrate chains to use actually all your tooling?
Actually, I think it could be used out of the box by any substrate chain. It depends on the tooling. If it's more like Starknet specific, but like a bunch of things I've spoke about, like benchmarking, like
yeah, I was thinking about benchmarking, especially.
Yeah, especially benchmark. Yeah, it's definitely something we should contribute more about it and maybe talk a bit more about it. On this, I mean, that's why we're here, to show this to the substrate community. But yeah, definitely, I think everyone should incorporate that into their repo. Would help a lot with transparency and yeah.
Yeah, that's awesome, because I can say as a parachain, I see a lot of tools that I could use that we actually miss, on any substrate chains. And the last question from me was, do you guys have any plan to leverage the multi-chain ecosystem of Polkadot and in one time in the future being a parachain to Polkadot and connect with other parachains?
Yeah, so all of this is like fully open source, and like it's just a matter of like people contributing and want to do something. So if anyone wants to like add XCM, for instance, to Madara, it would be totally possible. There are some people working on implementing Snowbridge, so with Beefy, the light client. So yeah, definitely interoperability will be coming. There are also some discussions about it, but yeah, I can't say much more right now.
Yeah. All right, thank you very much.
You're welcome.
Once again, thank you, Axel Vol.